So hello everyone, welcome back to another video. So in this video, we'll discuss another type of problem that is set mismatch. In this question, we have given a set of integer s which originally contain all the numbers from 1 to n, and unfortunately due to some error, one of the number is s got duplicated to another number in the set, which result in the repetition of one or more number and loss of the another number. So from the example, we can clearly say that if the basic intuition is the duplicate numbers and the number which has been missing are being the output in this given array. So if we take the array from 1 to n, and there could be the number of arrays that are been there from 1, 2, 3, 4, 5, and 6. And if I say that the 2 is not present in this array anymore, so what will be the output? So it can be 1, then 3, then 4, then 5, then 6. So here the missing will be 2. But I'm considering this array is being sorted. But what if the array is not a sorted one? Like 1, 4, then 3, then 2, then 1. Then this 1 is been repeating once. And for that, the repeating will be 1. When the size will be 6, the missing element will be 5. We have been given an array as input and the size of the array, but in this array there are some of the other things to be kept in mind is in the array number will formed from 1 to n, where n is the size of the array. And let's say I have the array from 1 to 7. So the array could be 1, 2, 3, 4, 5, 6, 7. But I can clearly see that this is an ideal case in which all the elements are present, but no elements are missing and repeating. But this is an ideal case in all the elements are equally present in the array. But the array is not like if we look, we can use the map solution in which, for example, I take the array where some elements are repeating and two is missing here. So for that, what we will create is we'll create a map and we'll check each and every element and its count. That is, 1 is present here, 3 is present here, 1 is present once, 3 is present once, 4 is present once, 5 is present once, and 1 is present twice. So we can say that the missing is 2 and repeating is 1. So the time complexity of this solution will be big O of n, where the space also you consumed as big O of n, because we are using this whole array to just traverse, and from each of that we are just create an empty array and mark all the element as 0. So either we traverse here or we traverse here. But what if we try to reduce the space complexity to big O of 1? On using the method of array, as I told you that we can traverse here. So for 1, we just mark it as 1 here. For 3, we again mark it as 1 here. For 4, we again mark it as 1 here. For 5, we again mark it as 1 here. For 1 element which is present at 1 is repeating. Here the count will be 2. So we can clearly say that the number here is not mapped, is a missing number. So previously we have been discussing about the logical and XOR approach. We will look after this step by step. First, we have an array of the array elements are 1, 3, 4, 5, and 1. Then we have learned in previous classes that sum of n natural numbers are n into n plus 1 by 2. The sum of n natural numbers. So what I'm trying to draw from this is that firstly, I take the sum from 1 to 5. That will be 1 plus 2 plus 3 plus 4 plus 5. And we'll take the sum of the array elements, that is 1 plus 3 plus 4 plus 5 plus 1. That will equal to s, and subtract these two different, and just subtract two different equations, that is equation 1 and equation 2, we'll get that s minus sn. Just write down what we have done till now. Minus 1 plus 2 plus 3 plus 4 plus 1 plus 3 plus 4 plus I plus 1 minus 1 minus 2 minus 3 minus 4 minus 5 minus 1. We're left out with minus of 1. Okay. If you are thinking that what if I just sum up all these elements and sum up all these array elements and just draw it as minus 1, that could be also the solution. We can also write it directly, but I have rather choose to just solve in these three steps. Okay, as we all know that the we have to mark it with to represent that what is the repeating element and what is the missing element. So I quickly mark it x as a repeating element and y as a missing element. So we know that by observing this array, the missing element is 2 and the repeating element is 1. So from that, we can say that repeating minus missing is equals to minus 1. That will be our equation number 3. And now in the next step, we'll take the sum of the squares of n natural number, that is 1 square plus 2 square plus 3 square plus dot 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 up till n square, that will be n into n plus 1 into 2n plus 1 divided by 6. If we draw the conclusion that by following the previous step of adding the array elements, we now add the squares of each and every array elements with the summation of the n natural numbers. What will be that thing is 1 square plus 3 square plus 4 square plus 5 square plus 1 square, that will be S, and sum of n natural number up till 5 will be 1 square plus 2 square plus 3 square plus 4 square plus 5 square, that will be S square and Sn square. So on subtracting these two equations, that is equation number 4 and equation number 5, after solving this, we get left out with 1 square and minus 2 square. That will be our x square and minus y square that we have previously discussed here. So we know that the formula that x square minus y square will be x plus y and x minus y. So after knowing that, from the equation number 3, we also have been got the x minus y value as minus 1. So this will be x minus y into minus 1 is equals to this value would be 1 minus of 4. That will be minus of 3. We will get from equation 3. Again, by solving it, we will get x minus y equal to 3. Then again substituting is equal to 3 minus y. Then substituting the value of x in equation number 3, that 3 minus of y minus y equal to minus of 1, that is 3 minus of 2y equal to minus 1, minus 2y equal to minus of 4, then y equal to 2, y equal to 2, and again substituting it in this equation, we'll get x equal to 1. We have understood that before we have marked these two by intuition, that repeating and missing, will we have solved these values and get these two kinds of approaches logically. Now we will see it in the code how it will work. So let's discuss about the code. So we will create a vector of int answer and we will pass it to find the missing and a repeating number, and then we'll create a length integer length of size to get the length of the input array and size, and again we'll create a vector of int name hash to store the count of the number of occurrence, that will be len comma 0, and after that, first step, that is step 1, is to count the occurrence, for int I equal to 0 as less than len I plus plus is the hash map we have to create that will see the array which have been passed is 1 based, so we use array of I minus 1 plus plus for. And second step that to is to find the occurrence, that is the missing number and the repeating number. And previously we have created this array. So in this array, so previously we have created this array. So in this array we will store both of the missing and the repeating number, and then we will return the answer. What I'm trying to say is that for int I is equals to 0, I is less than len, I plus plus, then if hash of I is equal to 0, then it will be answer of I is equals to stored 1 is equals to I plus 1. Or else if the hash will the hash is stored, we'll check for the repeating number, and then answer will store at the return position. That will be I plus 1 and return the answer. That's from the code. Yeah, it's accepted both of the condition. That's submitted. Yeah, submitted. Now let's discuss the XOR method. First, we'll discuss how XOR works. XOR works like if we XOR 1 with itself, it will be 0. Any number XORed with itself within the same number, that will always be equal to 0. But if I say 1 XOR 2, it will be different. How? See, XOR works in a manner that it always work in a bit that will be either 0 or 1. So I quickly write the table for the bits. What I'm trying to say is that there is 9 in the system in a binary form. So binary works either 0 or 1. Then if we XOR 1 with 2, what will be the value? It will be 110. That is 3. Answer will be 3. So this is the basic approach of how XOR works. So I'm trying to XOR the elements of the array with the n natural numbers, that is ones or twos or threes or fours or five, and we cut the similar number, that is 1 with 1, 3 with 3, and 4 with 4. We get the and 5 with 5, we get the 1 or 2, that is 3. Okay, but in this condition we have to scrutinize some of the things, that what could be some of the condition or edge case. So in this situation, what we will keep is we have to keep a bit count, and we know that a bit consists of a 0 and a 1. So what I'm trying to say is that each and every element of the array and the counting from 1 to 5, we will see that the first index of the digit that is converted to binary, we'll note it down and we'll separate it with 0 and 1 category respectively. So let's so see it carefully that I am just categorizing those elements which are starting from 0 and those which are starting from 1. So I see for 1, it will be at 0. So we will keep it in 0 category. For 3, it will be also 0. For 5, it will be 1. For 4, again 1. For 1, again 0. Again 1, again it will be at 0. For 2, it will be at 0. For 3, it will be at 0. For 4, it will be at 1. And for 5, will be again at 1. So you can clearly observe that the element which is occurring twice, that is even number of the elements that are occurring, can be cancelled out. Like if we XOR 5 with 5, it will be cancelled out. Then 4, similarly 4, and similarly if we see, we can cancel out 3 with 3 from 1 with 1. So we are lefting behind with these two numbers. So I know that one of these is a missing number and second one is a repeating one. So how I know that either one or two is missing or a repeating? So I will store this answer somewhere and I will check it with the array, and we will find that the 2 is missing here and 1 is repeating. So this is the whole approach we will do, and for the next step, see the code. So let's move on to the code. So first we will initialize with the XOR result, and then we will say that all the elements of XOR will store in this array called nums, and then the expected XOR value that will be stored in I plus 1, because we have to see each and every element from 1 to n. And then what we will see is we will initialize an iterator. We'll check the elements and finding the rightmost set bit of the XOR. And then we'll initialize with first element as 0 to keep the count, and we'll XOR the element, and the XOR expected value within the same set bit will calculate and will initialize the second value as the value which has been stored, that is XOR is been initialized with 0. We will take that value and XOR it first. We'll get the second number, and we set a flag that if there is a condition, that the flag will see that one at a time there should be either a missing number or a repeating number. So if the value of flag is false, then we'll find only one number, else it will return another number. So here is the same condition we have followed. So let's run the code. Okay, it has been accepted, and let's just submit it. Accepted.